Hey, I'm Justin from Toolpath, and this is Chips and Tips. With me today is Dave Stanbach of Carbide Cutting Tools. Why don't you introduce yourself?
Yeah, I'm Dave Stanbach, CEO of Carbide Cutting Tools. We've been in business for 18 years. We make everything carbide round tooling, and we also buy scrap carbide.
Okay. For a deeper backstory on you personally, check out episode 101 of Within Tolerance. But Dave very graciously agreed to come on and dive down a nerd rabbit hole with me on everything cutting tools. So I've got a bunch of stupid questions. Thanks for going through it with me. How big is your operation? How many employees? How many machines do you have?
4 employees, 5 with me, and then we also have Travis. He has his own business in the back, which I say a lot on Within Tolerance podcast, which everybody comments back to me, but he has his own business. We let him go back there for free to test all our tooling and start his own business, and he's been killing it. I think he's been back there more than 6 years. He does pay us rent. He has decided to pay us rent. I'm pretty sure that was his accountant was like, yeah, you need to start paying rent. It'd probably be a good idea. So, but yeah, it's been a crazy journey with him back there and then us over here. We have 6 machines, 2 chiller systems, filtration, a drag home finishing machine we just got, and then another like all cylindrical grinder.
Okay. Let's talk about scrap carbide for a little bit. You're offering like pretty good rates on scrap carbide. I sent you my jar of shame along with the mic kit for the episode here. Why are you out? Like, what do you do with scrap carbide, and why is it worth it for you to pay? What is it, like $14 a pound or something?
Right now we're at 15, and I'm going to announce that we're going to 17 for this podcast. It's the highest it's ever been, highest we've ever paid. And what we usually do is my dad was buying scrap carbide for over 40 years, and we just sell it to people that break it down, not all the way, and they don't do much to it, but they sell it off, and we make money on the weight. So we did negotiation weight, and we always make like about $1 to $2 a pound on it. And we do buy from like big corporations and everything, but the one thing we do is mail in. So everybody mails it in, which usually online, if I say, mail it in, and everybody's like, no, dude, you're going to steal all of it. There's no way. But people have been doing it, and right now we're getting about 50 to 60 boxes a day. And then on top of the other stuff. But it was about last week we did about 25,000 pounds. I can negotiate per price, and it's been going up and up. But last time, it was about 12 years ago, it was $14 a pound, and then overnight it dropped to like $4 a pound and stayed that way till just recently, pretty much.
Okay. Do you have any idea what's driving the price change on it?
I'm pretty sure it's tariffs, because all of the refined powder that they do that's made into blanks or other various things out of carbide, it comes out of China. So it's refined down. Not many people do it in the U.S. A couple do. I mean, there's only one person in the U.S. that makes blanks, which is HB Carbide, I'm pretty sure. That's the only one I know of. But also, our blank prices have gone up 85% this year. So that was like a big hit. But it kind of balances out with buying the scrap carbide.
Okay. So I sent you my bucket of carbide. I guess you'll send me a check, or can I just put it on my account for when I want end mills?
You could do that.
Is that a thing?
Yes, we do that. So if like you're like, well, you want some money, and they're like, you could put it towards that. We do that. So we usually just send out a check. It comes here, we weigh it up. We send you like a receipt of everything, and then we also pay $11 towards every medium flat rate box from the post office that's over 40 pounds.
Wow. Okay. Well, listen, I feel like not having my box of shame, I've lost something in my shop. Like I look at that every time I go to press the cycle start button.
Right.
So I'll have to, I don't know, I'll have to like memorialize that somehow and give myself some kind of a reminder.
Right. A lot because I sort through all the carbide that comes through, and every day I find ones that are like an aluminum cutter, and there's a big giant ball of aluminum on it. And I started saving those. And it real quickly, I like had a huge shelf of them. I was like, that's why it's all here. So I was like, yeah, I'll get rid of these and make money on instead of keep saving them. And like, I had pictures of all of them there, and I was like, nah, it's too many. I'll just let them go. But I should start saving them and post them on Instagram.
Yeah, I have a down cutting end mill. I don't think it's one of the ones you guys make, but the coolant burped on it and it chip welded like instantly. Yeah. Okay. All right. So everybody send in your scrap carbide. Don't hold on to it for sentimentality's sake. And then you'll get it back reprocessed into new end mills at some point.
Right.
But you don't do the reprocessing there. So you're not like recycling it and creating blanks and like soup to nuts making new end mills.
No, because it's probably like the dirtiest process on earth. You're not going to melt it back down. What they do is put it in like large hoppers, and then it shakes it back, and it just breaks itself down, and they break it down into a powder. But it's
like vibration.
Yes. So that's the only way to get it back to a powder, really. Because you break an end mill, it just snaps. So they just keep snapping it over and over in a machine. But it's an extremely dirty process. Not a lot of people like to do it, and environmental agencies will come and make sure. Yeah. And it's really high price thing to do, to break that down and stay clean and stay environmentally friendly and everything. So nobody really does it in the States anymore.
How do they separate it out for grade and all of that?
I have no idea. It's like the craziest thing ever that they would break it all down and separate all those things and get it right. But they do, and it works, and have at it, and we make money off it. So that's just what we did.
I talked a little bit to the folks at Kennametal, and they use some percentage of recycled carbide in their mix, and it's like a controlled percentage.
Right.
Yeah. Okay. All right. Well, so I have ordered a couple of end mills from you. I needed some dovetail cutters to make my HWR soft jaw blanks. I sent you like a really crappy 2D drawing. I like calling it a drawing would be an insult to drawings. It was like, a line drawing with like 3 numbers on it.
Right.
Is that good? Was that bad? Would you rather get a 3D model? What do you want to get when somebody orders tools?
Right. Perfect for us. The usual is somebody sends in a napkin drawing with their left hand with their eyes closed. There's never a tolerance on it. So we just always make it pretty much 0 tolerance. So there's no questions asked, but it's rare anybody sends me a blueprint and then I don't have a million follow-up questions for it.
Oh man, I'm almost embarrassed to admit that I think about tolerance on machine parts all the time. And I did not give 2 seconds thought to tolerance when I asked you for an end mill.
Right.
That's embarrassing. Wow.
Not really. Okay. I mean, our machines, we have filtration and chiller system. The filtration is a micron, and then it's also holds within a degree of temperature. So when we run stuff, it usually comes out dead nuts anyway. And we're making 3 of them. It's pretty easy to hold. The only issue is like when we start making custom tools for somebody, we're always going to test it because it'll cost me more time for them to go, it didn't work, restart, and then reset up and do all that. So I'll wait forever. And then like our issue now is I have 3 machines down because the chiller system died. It's been now for 4 months, and then I'm going to order another one, but it's going to be another 4 months. So that chiller system was connected to just a normal cutter grinder and then our cylindrical grinder. So I haven't been able to cylindrical grind anything, but luckily nobody's asked for any drills or step drills, which is the only thing we really do. And so we've been good on that. But usually, I mean, it's not like a big issue, but just follow-up questions. The other issue is having Travis test them since he's so busy right now. It's like I make an end mill, I get it done by 9 a.m. and I'm like, hey, we need to test it. But he's already busy running stuff. So I pretty much lose the whole day waiting for him to test it. But I could lose like 3 days restarting everything. So that's usually the game plan or the name of the game pretty much for customs for us, because it's a good, like I'll test it and it didn't work anyway. So like I would have been totally screwed doing that tool, sending it out.
Okay, well, let's back up a little bit. So I sent you my napkin drawing of a tool.
Right.
What do you do with that? Where does it go? What software do you use? What goes, like, before you put it on your machine to grind it? Tell me all the steps.
Pretty basic. I just look at whatever size the blank is going to be or what size I could, like, fit your form onto a blank. The worst part or the hardest part is the smallest diameter that it's going to go to. So that's, like, the first thing. Then after we do that, look at that. I usually just look at the blank price. And then pretty much the time of grinding doesn't really matter because, like I said, we're going to spend the whole day waiting for Travis to test it. Depends on how busy we are and when I set those into the schedule, which I'll set a bunch of those in the schedule, or I usually got to pepper them in so other stuff's running that I already know is good. But usually it's just the tolerance or whatever the angle is, because a lot of dovetails, they usually got to be like a dead nuts angle or a degree off, but it's not really an issue. The angles that get ground on tools, it holds every time, and most stuff we don't even measure angles because it's always pretty much dead nuts or within it, but we always just we set our own tolerance for make it exactly how it is. Because if we're in or out of that, then we send it out. They're like, it's a little too big. It's not tight enough for this or that.
So what does it get programmed in? Is it programmed directly on the control of the machine, like conversationally?
No. So you can, but it's not really that great. So we have so the machine has we run Anka cutter grinders, and they have their own software, and you have operations, you'll have fluting, OD, gashing and all that, or step editors, which we use the most, where you just draw stuff out, or you can send to DXF. I can insert to DXF, but a lot of times we have issues with, if you're using Fusion 360, it's not that accurate. It's great software, but it comes in, and usually I tell people send a step file of their part, just so I can see what they're cutting or what's going on, or if I can make other tools or combo it and reduce some of their tools out of their program. But when the DXF files come from Fusion, we take it to step file in SolidWorks. We're usually do they really want a 32.08476 angle? And you're like, no, it's just Fusion. That's just how Fusion isn't as solid as SolidWorks is, and other stuff radiuses come in goofy and all this other step file. And I was like, that might be a step file from the customer, and then they put it in Fusion, and then it gets a little murky. And I was I always have to call and be like, are you sure you wanted that angle, this weird ass thing and there's no tolerances or anything. So I was like, you always got to ask.
So that's why a napkin sketch is almost easier, because then you don't have to guess if this weird number is what they really want.
Right.
Okay. All right. So all I sent you was a 2D profile of my tool. I don't even think I told you how many flutes I wanted.
Right.
You did ask me what material I was cutting. So how do you decide, how many flutes, geometry, rake angle? Is it just, what the answer is? What's the process there?
I always think I do, and I'm always wrong. So that's why I can do the tool testing, but depending on the material, and then just our experience. But usually we're always wrong, weird shapes. But you say you want aluminum, and the first thing I already know a hook angle for the flute. It also, but it depends, because if you have different diameters, and their diameter is going to change within that angle. So usually we go a straight flute. Straight flute is the last thing we want to do. Usually we'll do, not it's an angle. You do a straight flute, but it's got an angle to it. I can't remember what that's called at
helix?
The moment.
Like a spiral or something?
Not a helix. It's still going to be straight, but it's just going to have, it's a shear angle is what it's called.
Okay.
So instead of being straight, you'll say 5 degrees, and it'll make that straight flute 5 degrees of an angle against the blank.
Okay.
But you'll get sharpness out of that. That's kind of like your hook angle. You can add a hook angle to a straight flute, but the issue with straight flute is so it'll bring up your spindle load on your machine, because it's if you think of a helix, it's cutting separately all throughout that. Where if you have a straight flute, it's like taking a paddle and hitting water with it straight. So it's just gonna go straight to the your machine, spindle load and everything. It's gonna bring it up, but we try to avoid that, because usually I'll ask what machine are you running it on, but the lower power machines, you're doing some kind of form and it's a bunch of different diameter changes. It's not gonna be happy with that. The tool's not gonna hold up, because you're hitting 100% tool pressure every time a flute hits and cuts. So that's some tools, they need to be straight flute, but it's very rare we ever make straight flute, and I try to avoid it as much as possible.
Okay. Are most tools made with a shear flute or a helix flute?
Helix. So you have helix, and that's your spiral, and then shear is just a straight helix type scenario.
Got it. Okay, so that's really interesting. So, I would assume that if it's an aluminum, unless somebody asks otherwise, you're going to make a 3 flute tool, right? That seems to be the compromise everybody goes for right now.
Depends on what it is, because if it's a form tool, we want it to last as long as possible. And usually we try and go as many flutes as possible, but the other issue with as many flutes as possible is spindle load. So that's going to bring spindle load up, so that's why I always ask what machine it is, but usually just try and go. If I want to do a ton of flutes and make the tool last, I'll just say take multiple passes instead of taking one pass. Like it'll just make it, even if you're taking multiple passes, it's going to last really long time.
Okay. I mean, generally people say tools in aluminum last forever anyway. Do you
Right.
think it different? Like they last forever, but they last for more forever if you make it 5 flutes?
It really depends. It's not like adding more flutes helps sometimes. It'll really mess up, like it'll bring in chatter. So once your chatter starts, you're not going to be able to get it out. So less flutes, less tool engagement.
Okay.
Because less flutes you have, typically you're going to have a better finish. It's very odd that it is that way. It depends on the material too. Aluminum, like 3 flute, holds up pretty well for that. It's like a balance of holding up and giving a perfect finish. And then
Less
also
flutes gives you a better finish. I didn't know that.
usually it does. Usually in like every material we tested in, less flutes does. And you have a lot less tool pressure, a lot less chance for chatter.
Right. Okay. Okay, so I send you my crappy napkin drawing. You convert it, or a step file. I never would have thought to send you the geometry of the part. So that's a good tip for anybody who's asking for a form tool, is like, hey, this is the actual part I'm cutting. Because then you could probably suggest some improvements to whatever stupid tool design they came up with. And then, so we agree on some part geometry. I don't think you told me or like went back and said like, hey, I'm going to make you a 3 flute tool. Do you ever have customers who like specify flute count or like get really into the details on like wipers or edge geometry or anything like that?
Yes.
Okay.
I always just tell them like, hey, I know you want this thing on here, especially wipers. I have tested wipers to the moon and back. I've never had any success with wipers over a small corner radius. A small corner radius and the right speeds and feeds. Like, because we, in the back, we machine a lot of keyboards, and they have to have, in the bottom of the keyboard is a flat floor, and it has to be like perfectly flat. I went through many sleepless nights trying to figure out how to get the...
Like a computer keyboard?
Yes. So we machine tons of those, and the bottom has to be flat because then we bead blast them. And if you have any dig in from the corner radius or run out of the tool, it'll show on the floor instantly. And the people who buy keyboards are just, they are the most picky people about machine components I've ever seen. And the biggest part of our business we sell to that make the bliss blades for GE turbines, and they don't complain as much as people that buy keyboards. But like, I mean, the keyboard, I get it because they buy it, it's expensive, and they love it, and they stare at it, and they just like, and they're like, oh, see, it's digging in here, or the tool did something here, or this finish isn't that great. And they are very picky about it, but it's made us better machinists, and it's helped me develop a lot of tools.
Okay. So you're saying for floor finishes, if I want a solid carbide end mill, not an inserted tool, I guess it would apply to an inserted tool as well.
Right.
You want a small corner radius on the edge of the tool is to help improve the floor finish.
Yes. So all our finishers come with a 5-thou corner radius. It's worked the best. We've gone through a million different speeds and feeds, but we found that it works like on every single part. We just take off the 1 thou 5/10 off the floor, 10,000 RPM or 7,000 to 10,000 RPM, and 66% step over for like the most perfect floor finish.
66%. Okay,
yeah,
interesting.
we went through the ringer on that 70 to 60, and 66 works for like everything. So if we were facing like off a part too, we always do it with like an end mill, or we need to get like a perfect flat floor finish to start something, or like we have a tolerance that's super tight for a flat floor finish. That works the best.
Okay. All right. Interesting. Yeah, I think I usually use like 90% step over or something.
Right.
So maybe I'll adjust that.
The bigger the step, everybody's like, we're not taking much off, so 100% to something close to that step over with a little bit of overlap, but that didn't work out too well, and you get dig in, or you have your machine's got to be perfect. For flat floor finish, your machine's got to be perfect. If you have wipers or a tool with wipers, it's not going to help you unless your machine is absolutely perfect, ball barred, laser leveled, and all that.
Okay. All right. So you don't like wipers. That's what I'm getting.
I've never had any luck with them. I've seen tools that have them, but I think it's just marketing. And then I don't know many people that have used wipers and they go, yeah, this is how we get a perfectly flat finish. And I've never heard it. And I haven't seen them work very well. I think it's just a marketing gimmick, really.
Okay. Interesting. What about carbide grade? Like, do you choose different carbide grades depending on steel, aluminum, or anything like that?
Not really, unless it's called out for a blueprint, but usually every tool we make is 10% carbide grade. I've been working on using 6% carbide grade for aluminum finishers. Just because, well, aluminum finishers, they're like the hardest tools to make, because you have any intricacy in the blank already, then that's going to pass off in the part. So like I always tell people when they have aluminum finishers, don't lay them down on your table, your dirty table next to your machine. It's because aluminum finishers have a leftover bit of blank on the OD when they cut. It's like a fourth out, what we call like a feather edge or a circle margin. It's leftover blank. So that blank has to be perfect. Usually the ones we do it on are a polished blank. We polish the flutes on our tools, and then we don't do any honing on any of the finishers for aluminum.
Okay. So because aluminum tools, you want them to be sharper, so that's why you don't hone it?
Finishers, yes, but roughers, we do a brush hone, which is a 600 grit brush, and then we do a drag hone machine, and we do 2 medias of that. So we have 1,000 grit walnut media with diamond paste in it. We run it in there it's like a 20-minute cycle time for that, and then we do a polishing corn cob media. That's 2,000 grit, and they run in there, and that polishes the cutting edge, but it's like a 2 thou radius on your cutting edge.
Oh, wow. Okay. And so then it's a rougher, but not a finisher.
Right. So we also have chip breakers in it. The chip breakers are always, at first, a lot of people, they buy the rougher and they're like, the finish is great. And then they don't get back to me 20 minutes later when this tool starts breaking down a little, and then there's lines in it. And then they're like, we do need a finisher. Like, it was looking great at first, but we definitely going to need a finisher.
Okay. All right. So I think it sounds a little bit like a combined rougher finisher doesn't really exist.
Not really. And then we've been getting, it's always been a love-hate relationship with a lot of customers for the knuckle-style roughers. Like, we used to make a lot of them, but the issue with those is if you're running knuckle-style roughers, like I just was totally read
Is knuckle-style like corn cob?
Yeah, the corn cob style. Okay. So the knuckle roughers, the issue with those is you can run them hard. There's no spindle load. You can run a larger diameter tool on a lower-powered machine and have no issue. They run great. The issue is the chips that they make. So it's either, I have people call me and go, I love this thing. The chips are great. I love it. Then everybody else calls me and they go, yeah, my machine's like ruined. There's this aluminum sludge everywhere. I don't know what to do with it. And like, the tool was great, but the chips aren't great. I'm like, well, the chips aren't really my problem, but I started recommending, I was like, you want to run a knuckle rougher, you have got to get a screen or filter paper, or you got to have a good filtration system on your machine. And you'll be happy, because I saw a guy the other day and he was just using a chip breaker and he still had chips and they were piled up to the door. And I was like, you need to switch to a knuckle rougher, but you really got to get your filtration system under wraps. Like Swarf, or I think, what is the name of the company that makes
Swarf Unlimited? Yeah.
Swarf Unlimited. They make a screen that'll catch a majority of the chips, but you still got to pretty much have filter paper, because the one I'm about to develop, you're going to be able to rough super hard with it, and it's going to make a mess instantly, and you got to keep an eye on your chip management. Where a chip breaker, you really don't have to. You can run it unattended. Just depends on the part and how much material we're removing. But, I'm about to redesign. I redesigned the knuckle rougher on simulation, but I'm about to start making them and running them and find out really how hard we can run them and everything.
Back up there on simulation. What are you using for simulation?
Oh, so yeah, I kind of skipped that question. So on the Anka machine, they have their own software, and you just have operations, and then it's just their own software. But actually, like because you have Anka CNCs, you have Walter.
You mean simulation for the grinding, not simulation of the performance of the end mill?
No, just of the end mill, and you get to see the whole machine moving and what wheels you're using, and if they're in the way or which way they can move. It's pretty important. You're not going to be able to run anything on the machine unless you go to the simulation.
Yeah, I thought when I first got my Speedio, we run a lot of knuckle roughers or corncob roughers,
right?
Just so that I don't have to think about chip management. And the Speedio doesn't have even like a decent grate at the bottom of it. Its stock chip management's pretty poor. So I managed to fill the entire bed up with chips,
right?
The entire coolant tank up with chips, and I didn't realize it. And then I started getting like major foaming problems because I just didn't have enough coolant volume.
Yeah, and you get a sludge in the bottom, and then you start losing coolant capacity, and then you're like, why aren't I getting coolant? And then your coolant pump's completely packed with these like sludge.
Right.
So you're like,
So then I had to grab the Freddy and clean out the chip bin and everything. So that's why I actually built like Andrew Henry gave me the idea, but I built like a tray for my coolant,
Right.
and then the filter peeper goes underneath it, and I keep like a 1-inch gap between the bottom of the stainless steel mesh and the filter paper, and that seems to work really nicely. But for sure, roughers are nice for chip management. But yeah, if you don't have some way to keep the fines out of your coolant tank, then that's a problem.
right. And you got to keep an eye on it. It's going to fill
Yeah.
filter paper up quick, and you can't.
Yeah.
You can
for
walk
sure,
away from
yeah.
a part, but the second you start running off production, and you got a big part that's removing a lot, and that like sludge will start being a nightmare for you.
Okay. So the next question I have is, and you mentioned it briefly a little bit in terms of blanks, but like, is everything coming out of pre-cut blanks of a fixed length for you, or do you have like long rod and you'll cut the tool out of that rod, or how does it work?
You could get both. Right now, there's not like a shortage, but really hard to get material for blanks. So I go through a bunch of different companies, and all the blanks are pretty much made. I mean, there's a couple made here, but they're really pricey. I like Kennametal. Kennametal's the priciest of them all. I only buy them if it's for a blueprinted, but they come in rod and cut to size. We usually buy cut to size, but have been having a bunch of issues getting cut to size, so we buy the rod and cut them down.
Okay, so you can buy your blanks straight from Kennametal? I didn't know that.
Yes, you can buy blanks straight from. We buy a lot of blanks from Kennametal actually because we have a lot of blueprinted tools for them.
Okay.
They are the priciest, and it's kind of hard because big production shop we do. I really can't increase the price of the tool even if the price of the blank goes up. So I just gotta I gotta wait it out till the price of the blank can come down. Kennametals are made in the U.S. They just are pricey. I buy because we've been in business for 18 years. We've been buying from, we buy a Chinese blank called CY. I've never had an issue with any blank. We buy $500 to $1 million in blanks a year. Never one issue in like 18 years. But then I've recently switched to Hyperion Blank, which is a German company. They actually make it in Germany. They bought another company for the coolant through blanks. So they have a large assortment of coolant through blanks already made for drills. And then they moved a facility from China to Mexico. So most of the blanks are coming out in Mexico, but us testing in the back, they've been the best blanks I've ever used. They hold up the most because in the back, we run a ton of Inconel 625. So and we develop all the tools here and run parts, subcontract for a company around the corner, and they run even more Inconel. And all they run is Inconel 625, and we usually have it on a machine all year round. And all the tools I've developed, we've tested every blank that's out there on the market, but the Hyperion, the blanks they have hold up better than anybody else's blanks.
Okay, I'm going to circle back to Inconel because I have some questions there. But if I'm sending you, a request for a custom, what do I think about in terms of like governing the cost of that custom? The price you gave me on the end mill I bought was exceptional. It was a very great price. But like, could I have done anything to make it cheaper or?
Not really. I usually keep our prices super low because it's a lot of work to not really quote a custom, but like everything I got to do to make tools. We're ISO certified, so a lot of paperwork and red tape for me to make a tool, even if it's 3. But I usually keep the price low because I don't want to do all that work quoted. A lot of custom form tools, I have to like simulate it and make it on the simulation machine, and I have to think of new ways to do it. It's not straightforward, so it takes me a while. And I was like, I'm going through all that work. I'm going to keep the price low so that they're going to buy it. Like I want them to buy it. And then most of the time, like I'm looking at a tool and like, I look at it straight up and just go like, this is going to be really high. Like the price of this. I don't know if you want to go form tool or anything like that before I start getting in all the red tape and doing all that. And where I have to make it, grind it, test it, and do all that. So I keep them pretty low. We make money off of them, but not a lot. I usually do it just to help people out. And like Instagram, I see all these starter shops. I always send them tools, and if they need help with stuff, like I want them to get these subcontracted jobs and keep them, and then turn their like business into an empire off all the subcontracted. Because the company I'm doing for, I'm going to be like, I don't know how they're making our parts so cheap, but I want them to keep doing it and get more business. And a lot of people on Instagram, Reddit, and Facebook, I've like just been with them their whole journey of their company and watched them grow and make up pretty much all their tools and everything for them.
That's an amazing story. I wish there was a way I could be like, I don't care about ISO, so just make it and send it to me.
Right. Well, I mean,
I'm sure you can't do that, but
I mean, ISO's not really involved with like our customs. It's just our other customers that require ISO for us to make anything for them. So the customs aren't really involved with that. We are ISO, and I comply by all the ISO, all the stuff for it to make tools. But just customs, I know it helps out a lot of people, and they're trying to start their machine shop and schools. Like I was at the school yesterday, and we've donated about $10,000 worth of tools to schools and shops and everything, which I don't like. Like, I do advertise, but I don't like to advertise. I like to keep handing out tools for free as our advertisement.
Yeah. Okay, let me ask a follow-up question then. Now that I've ordered that tool from you, if I needed more, is it still a pain in the butt, or can you just throw it on the machine and run it now?
No, throw it on the machine and run it. Just knock it out. And then usually if it starts turning into a tool that you're going to use a lot, you order 3 and I'll be like, hey, you want me to make 9? Is this going to be like a permanent thing for you? I just put them on the shelf. It frees me up for a lot of time to do the customs that I got to wait a whole day for testing for. So I do that a lot, and I stock a lot of stuff for people when they start. The customs start, really, that part turns into a production thing for them.
So how often do you make a custom and then it doesn't cut and you have to go back and make it again?
Usually not at all anymore.
Okay.
You've
got it dialed now. Okay.
Right. Yeah. And then because we always make end mills for people, and people call us up and they go, I'm using this end mill. And instead of me trying to figure out a new end mill for them, I go, I could copy it. I can make it better. I could test it in-house, get better coatings, send it to you, and then you start running it. And you got to keep me updated of how it's running. And we do that for a lot of people. And it's a time saver because end mill designs are like snowflakes. There's like a bazillion of them. And they go, well, I'm running this. Can you make something better that'll do better? And I have no idea until we start testing. If you really want to get into it, it's going to take quite a while because the testing it's not like an easy feat. And I got to wait for machines to open up to start doing the testing. And
right.
We've done that a lot with thread mills. Like I've done a lot of custom, we do tons of custom thread mills. We make every shape thread mill on the market. And it's just when people start doing that, I could do testing because, the issue with testing for those is it's something we've already tested a lot, and we just want to refine it for people because a lot of parts for automotive manufacturers, they want them to last. They go, when they buy this tool, it has to last this certain amount of parts. And I go, I can't test for 10,000 parts. You have to do that and keep me updated. We do that a lot. Like for automotive manufacturers, that happens a lot with form tools, customs, and all that.
Okay. If let's say you made a custom tool thread mill and it's not lasting as long as they want, what do you change?
Usually the edge prep. So we change the edge prep and coatings. So we've tested coatings, just all of them. Every company that does coating, even if Goering, the tool company, they will coat tools for you. A couple other ones do, but then there's places that they just specialize in coating. But we have a local coater. And they have a couple places in the U.S., but we've gone with their coatings. They've just held up the best. And for aluminum, we use, I think, about 3 coatings from them now that are great. 4 actually. So we use because they always have the newest machinery and everything. So we always just go with them, and they have new ideas for coatings. And I'm like, yeah, let's try it. Because it'll keep me ahead of the game when somebody comes in and says, this isn't lasting long.
How do you account for coating thickness when you make an end mill?
Tight tolerance stuff, we can't coat it anymore because the newer coatings that have come out are sputtered on and they're not even. They say they can control the thickness of it, but they come a different thickness every time. We have an auto inspection machine, and we'll inspect diameters before. Well, we'll inspect diameters when we cylindrical grind, make the tool, and then before and after coating. And I've had a bunch of tight tolerance like reamers. They had to meet a requirement of how many parts they had to make. They did with the coating, but we just had so many issues with the coating going oversized and undersized, and removing the new coatings takes like a month. So, and then you try again, and then it comes back thicker or thinner, and you're just totally screwed. So tight tolerance stuff, we quit coating.
What is tight tolerance in this context?
So usually they say you could be 2 to 4 microns thick per side on a coating, and they've been coming like 8, like 4 to 8 or 2. It just depends, and it's never consistent. So I just said, yeah, tight tolerance stuff, we can't coat it anymore. But like end mills and stuff, yeah, I'm like, yeah, coat it twice. Let's try coating it twice. Let's do it once. Let's coat it twice, and then we'll drag, hone, polish it, and then we'll see if that like helps with lubricity. And I mean, we do that all the time. But the new coatings, like we have DLC, which is diamond-like coating. We do that for aluminum, but it messes up the finish because, like I said, it's sputtered on, and the issue with sputtered on is it's very uneven, so it'll pass right off in the part. So I quit coating finishers. It's not going to happen. Even though, well, aluminum finishers, the best one on the market is the YG1, but it doesn't last. And it is coated, and I don't know what they do. It's just like a drag hone polish after, which I've tried, but drag honing is also uneven too, so it'll pass right off in the part. Where if I buy a blank and it's already polished, that's the finish you're going to get. It was like years of R&D and trying stuff. It comes back to the keyboards of getting the finish perfect from a finisher. And then the thing is, we're trying to get a perfect finish on used, beat up machines, and that's what everybody's using. So that's what I have to make a finisher for. So I had to quit. I've tried a bunch of different coatings for finishers. There are some that are very thin that worked, but the price has skyrocketed because of tariffs. And just availability, and I have to ship the tools out, so it would have to be an added price to the tool with the added price of coating. Like roughers for aluminum, like what we do is DLC. It's diamond-like coating. It's really hard, so it's really loud too. So the issue of it being loud is like if you have a really small brother, I've had a couple customers with a really small brother, like, I don't think this is going to work in my machine. It's really loud, and I'm kind of scared to run it, even if I go slow or whatever. It's just loud. So I've had to go into like the crappier coatings. It'll last still.
Wow, the noise the end mill makes changes from the coating?
Yes.
That's amazing.
Right, because of the hardness of the coating. So DLC is a really hard it's the hardest coating there is. So, right. But it works wonders for tool life. Like it'll double tool life in aluminum, brass, and non-ferrous stuff. But then the other coating we use is ALCRN, and it'll double tool life in steels, hardened steels, exotics, everything. So we love ALCRN, and now they have a new coating that they just came out with, and I just tested it. It's called Aurora X, and I can't remember. It's like every coating in one. I think it was like ALTISI, and it comes out rainbowed. And I just had so there's like a competition at Eaton Aerospace. They're doing they have a line of machines, and they're running titanium, and they were like, everybody bring in your end mill. We'll do testing and see who turns out the best. And they went up against every manufacturer out there, and our tool it lasted twice as long as the second best tool. And I won that contract, even though it's like it'll keep my machine busy forever, running these tools, but it's like really low price that I make on it. Cause you still have to beat their price. Margin. Yeah. So you have to beat their price and performance, which is, I mean, that's pretty much like our motto for our company. Price and performance will beat everybody on that.
The Eaton World Headquarters is a mile up the road from my shop.
Right, and they're everywhere. Yeah. There's a bunch of them around here. And same with, we have Linamar, who does subcontracting for automotive manufacturers, and we're about an hour from Asheville. There's 5 giant plants there. They're everywhere.
Yeah. Okay, my mind is a little bit blown that like the sound the end mill makes would be affected by coating. So if you're saying if I took the exact same geometry but uncoated versus DLC coated, the DLC one will sound scarier.
A lot louder. 100%. We've done it in here because I was like, we're all laughing in the shop when the guy contacted us. He goes, "This thing's loud," and he goes, "My machine's not powerful." And then I was like, because I never really think about that. I'm like, man, most of our tools go to people that are like in a garage, not that powerful. And I was like, well, I know it performs. We've tested it here because we usually test everything like uncoated because we don't wait for it to get coated. And then I was like, oh, dude, we got to get some coated in DLC and run it. This guy says it's super loud. He's got the little tiny brother, and he's just like, it'll hold up. But he's like, it's unsettling. And I'm also it's in my house. So like my machine's running at night when I'm trying to sleep, which I've also had that too. I've had people contact me like, hey, can you make this tool not loud? Because my kids can't sleep at night when my machines are running lights out. Stuff like, yeah, we can do that. I'll figure something out.
Acoustic optimization of tooling.
100%.
The very, very first paid job I ever did was this stupid steel job that I had no business taking. I had no idea what I was doing. And my machine was right below my bedroom, and I went up to go to bed, and it was supposed to run for like another hour. And I said, does it sound loud to you? To my wife. And she was like, I don't know. It's always loud. But it sounded louder to me. And sure enough, I went downstairs, and the end mill had started to like fall apart.
Right.
And it was getting like way louder. So I changed out the end mill and kept going. But man, I didn't know anything about feeds and speeds or how to run those tools or anything then. So I can appreciate wanting quieter tooling for the home shop guy. That's an interesting point. You should. That's like a legit like end mill line. Like so quiet your wife can sleep while you're cutting or something. You know. Okay. Let's talk about thread mills a little bit. I really like thread mills. In part because I don't want to keep every tap and drill stood up, and also because I broke a bunch of taps early on, and so I just don't like scrapping parts. But I've had the counter argument is like, well, they're expensive and they wear, so your comp, the amount you have to comp in to keep your thread tight changes over time. And then you can get single pitch ones, which are the ones I like to use because I can do like 4 threads with a single tool. But they're slow. They're really slow.
Right.
So I know you have a bunch of multi-pitch threads, multi-pitch or multi-tooth ones on your website. Right. Do you guys make single pitch ones?
We do, but that's the other thing. Having a website is really expensive. In our catalog, we have about 30,000 items. So everybody's always online like, why can't you tool companies just put a buy now card on it? I go, well, it's 30,000 items, and Helical's been selling tools online. They have a cart next to it, but it's not a buy now cart. And I was like, they make pretty good amount of money, and they're not doing that on their website. So you want me to do that and keep my tool prices low and put everything online? Like, I don't have anybody to put every single item number on there, which I just have like the basics. And we used to have a lot of other stuff on there, but nobody ever bought it. Like I said, like aluminum end mills, yeah, you have a rougher, a finisher, and that's it. But like every other material besides non-ferrous, there's a million different types of end mills, and like they're all specific to that material. And I can't have those. I mean, putting them on there isn't the greatest, and it just, nobody really buys them because they're all, like I said, they call me and go, I'm already using this end mill. Do you have something comparable? And I go, I do kind of, but I don't know what holders you got. I don't know what machine you're running it on. I think I can make something better, or I could copy it and make it better, make it cheaper. And then you hit the ground running. We do a little bit of testing, and you're not going back to square one trying to figure it out, lose a bunch of production time. So I kind of took them off the website. It was just a headache when it's a lot easier for me to copy and make something for them. But aluminum end mills are pretty straightforward. So you have rougher and finisher. I need to get a lot more sizes on there because, well, I mean, when you stock tools, you also have to pay taxes on all the tools you stock. So I try to like not have a million different weird sizes, which that's what everybody wants. They're like, you don't stock anything. Where's your 3/4 by 8 foot long by 44? Why don't you have 44.6 thou radius on it? And it's not coated. It's going to take 2 weeks to get that. I was like, I don't know where you were going to get that stock somewhere. So that's usually what everybody calls me about. So it's just like, it's all customs, and I hate to call it custom because I'm still going to look up. I mean, Helical's website, I know that website better than anybody else. It's where I do a majority of my quoting. Like they say, oh, I want this end mill. I go look there and go, well, that's Helical got it for. Like, I'll go 20% cheaper all day. I was like, I don't know why the price is so high, but I use them for quoting a lot. Anything else, really, I just go by the size of the end mill or whatever it is. But when I just beat price, that's like the easiest quoting, when I can just beat somebody's price.
Okay. So that actually leads into one of my questions I have. I know, like, if I walk into a job shop, a machine shop, I kind of know, like, first order what I'm going to expect, right? Like, 1 or 2 man shop, there's going to be somebody who's running around like a chicken with his head cut off, getting parts on the machine, answering emails. And their quoting is like a big sort of like quote as fast as you can. It's always a distraction. Some people will bunch it up at the end of the day, but it's a pretty big part of their workflow that kind of just has to happen.
Right.
How's that work for you? Like if I send you a request for a quote, do you have to stop everything? Are you always getting bombarded with requests for quotes? Do you batch them at the end of the day? How do you deal with it?
Probably about 30 to 40 quotes a day. I could quote stuff like almost instantly because usually it's Instagram. They ask me if I can make something, send me a link to it, and like it's an instant quote.
Okay.
Because I run our Instagram. I run pretty much everything and do all the quoting and run the whole shop. But quoting's pretty easy. Like I said, I just go to Helical real quick for most of the stuff or sizes. But like all the custom stuff, I can quote it super quick, and I know what it's going to take to make it and everything. But the other thing is like when we quote, it's sometimes it's a longer process because like if I say send me your step file, whatever your part is, because I don't want to go like, oh, how far is this cutting? Where's this cutting? Is this cutting? Is there a rate? Like there's just so many different variables that they don't add into their tool. So I'd rather see the step file and see like what it actually is cutting. Or I can suggest to them like, hey, to throw these 2 other radiuses in here. I can make this thing just cut it in one shot. Or we could drill this, thread mill this, and chamfer, counterbore, and everything all in one shot. Like you want to do that? Like I can make a test tool, test it, because this could be like a standard for us. If we just do that and you just be helping me develop it. I do that a lot. And then, like I said, like if it works for them, then we just stock it for them.
Okay. TSC. If I want a tool with TSC versus no TSC, what does that change? Price? Does it change how you design it?
Just price, really. Just to make up for the blank. Cooling through blanks aren't that much more expensive. The issue is like when you buy people that stock those drills with cooling through, they're so high priced because they're always making those. So they have them, but their price is high. It's in stock. So you're paying really for that stock price. So that's why like they'll stock thousands. Like I used to work at, it was a company called Precor. It got bought up by Stanbach and then they changed it to Walter. And I still work with them. I'm always over there. They just make drills. That's it. Every size you could think of, but that comes at a price. You're stocking tons of stuff you got to pay taxes on. So you pretty much got to, that gets passed off into the price of the tool. Which same thing for us for that, but we stock a ton of through coolant thread mills. But I buy like tons of blanks at a time, and it helps me for like about a year of stock. So I can hold a price for a lot longer on that. Drill coolant through, it's not much more than a normal coolant through. The only issue is it only comes in metric sizes. Some people do have it in standard. So I always have to tell people, like, I know I made the drill on a standard before and it didn't have coolant through and you want coolant through, it's going to go to a metric size. And they're just...
On the shank, you mean?
Right.
You can grind whatever size, the shank size.
Right. But like, well, that's another thing. On customs, I always tell people avoid it. And like, because everybody loves to go, oh, can I have a reduced shank to hold on to? Like, because they're like, oh, if this reduced shank is smaller, the tool's going to be cheaper. It's less carbide. But that's the hardest thing for us to do is to H6 tolerance or reduced shank. There are some like smaller machines that they can only go to a certain size so that...
A reduced shank. In other words, the shank is smaller than the tool?
Yes. So you're like a 3/8 shank on a 3/4 headed tool or something like that. Okay. But like a lot of people, they do their customs. They send me a blueprint and they go, I want it on 3/4, but can we reduce the shank? Like, because they think it's going to reduce the price, but it's going to increase the price a lot because I have to grind it to an H6 tolerance. It has to be perfectly straight or else I'm going to have run out in the tool if it's not ground right. And I was like, the blank already comes. Get like another ER collet or a holder or something else. It's going to benefit you in the future if you want to buy tools from us, because then you're going to buy bigger tools and they're going to be a cheaper price because I don't have to reduce the shank size.
Okay, interesting. So normally for you, a process would be the shank is just coming straight off the blank.
Right, and the blanks are, it's like the tightest tolerance ever. If it's 1/2 inch, it's 1/2 inch. It's within, I've never seen blanks vary outside or under or over that ever. Like they're dead on them. Like it's already done. Like, because I usually recommend like, let's not reduce shank it so that you have clearance. Let's put an undercut behind the tool that I make for clearance instead, which is super easy. And it can be a process done in the machine while it's grinding the tool anyway. Where like a H6 tolerance shank, if I reduce it, it has to go to our cylindrical grinder, which is, this thing holds dead nut 0 tolerance, but that requires a lot of setup for it. So we try to avoid using that machine for a lot of we use that for drills. Yeah. If you want tight tolerance. Yeah. And, any cylindrical grinding we have to do for reduced shanks, it's great and everything, but the tolerance is super tight and the setup it's a lengthy one. And to hold those tolerances, you got to be quick because the machine's going to cool down and you're going to lose your tolerance and you're not going to get a repetitive tolerance for everybody that wants like a 1 to 3 piece tools.
Okay. I don't know if you'll know the answer to this one, but I was skimming the website and I saw that like your quarter 20 has TSC, but not the quarter 13 thread mill. Why is that?
Probably just because nobody buys it with cooling through. I mean, we can make it. I have the blanks if you ever needed it. Yeah, we do that.
Okay, so it's not that there's like some geometry difference that makes it so you can't have TSC on that. Okay.
No, it's just an odd size. Nobody really calls out threads for those. I know right after I hit this, someone's going to mess with you like, that's the only thread we do on everything we make. So.
Okay. Do you give out libraries for your tools? Like, will you generate a Fusion or a Mastercam or Hypermill tool file for any of your tools for your customers?
I will send out a DXF. Most of the custom forms we do, I'll send out a DXF. Then they can input it and program it a lot easier. I don't have any, I don't know. It's really, I guess it's just a DXF and you can turn it into a 3D file and then put it into a tool library, which I need to start doing that for all our thread mills. It'll be a lot easier for everybody, which you really don't. I mean, it'll help you with programming, but it's probably easier to just look at the dimensions. They're fairly basic anyway for all the thread mills.
Well, a little bit selfishly, the reason I ask there, and I have a follow-up question, is that we have this tool recommendation engine that we've added.
Right.
So now it's like, how do I know? I like to buy my thread mills from Carbide Cutting Tools, but now Toolpath can just be like, buy this thread mill. This is the thread mill you need.
Right.
But in order for that to work, we use a Fusion tool library. But also, I have seen that lots of customers, like, it's a sort of a reduced friction. I have noticed, like, using it that, if I have to draw the tool myself, like, that's more work than if I can just download it, which does sometimes affect my personal purchasing preference.
Right.
Like, how quickly can I find the tool I need and how quickly can I get it into CAM?
Right.
Do you have like a spreadsheet somewhere? Like, this is all the geometry of all of my thread mills, or is there a file somewhere where that exists?
Yes. So we have like a paper catalog, and I recently I have a PDF, and I recently just found it as a PDF after it was made in 2016. I was like, it was hitting on my dad's old computer like forever. I've been sending it to everybody. On the back, it has speeds and feeds and all the dimensions of all the thread mills on it.
Okay.
And I think we have some of the dimensions on the website for the thread mills.
Okay. Well, maybe I'll try to make a tool library with some of your thread mills and see what I can do with it.
Right, because I did run into the issue. Zap had a customer, and they were making a triple start thread, and it was an Acme, but the distance was... So when you make a triple start thread, when you go 360 around making the thread, you're going to have to travel 3 times the distance for that thread. So the guy was calling me and he's like, hey, this company, we're selling them a machine turnkey. You can make this Acme single point. Will this work if we go triple start? I was like, yeah, it's totally fine. It'll do it. We've done tons of triple start stuff. He's like, it's a long distance. And then Zap called me in because he's helping him out. And he's like, I simulated this and it just wallers out the weirdest thread shape ever because of the distance. And I'm sitting there telling the guy, like, yeah, we'll make it. And we were like, we're about to make it. And then I had to call the guy and be like, no, Zap proved me wrong that this thread mill is definitely not going to work. You're going to still have to stay with the tap. And it was for brother. And I was like, this is a giant tap. I don't know how it's going to work. They're like, they have taps they use at work. I was like, I don't know if the brother's going to push that thing, but I was like,
high torque spindle. Yeah.
I totally screwed myself. I was like, yep, if I had that tool drawn out in the tool library, that guy would have figured it out real quick at brother and been like, nope, you guys got to stick with the tap. And it was a long drawn out process because he wasn't sure. And I was like, I kept telling him, it's going to work. It's going to work. And I was like, nope, if I would have just drew that out of DXF and sent it to him, he would have been golden, but there was no way that was going to work.
I hope that over the next 4 or 5 years that we'll move to a world where I hope all the tool manufacturers will have to provide some sort of data about their tools.
Right.
Because going through tool catalogs is just an awful experience. Like you said, nobody does it right.
Right.
And I very ruthlessly critical of the Kennametal one. sometimes
Right.
when I talk to those guys. Harvey and Helical have like one of the better catalogs to evaluate, and even theirs is still not great.
Like I
And
said,
I think,
super
go ahead.
jealous of their websites.
Yeah, I think the reality is that it may just not be possible to make a really good catalog for tools, just because, like you said, there's so many options, and some people want to filter geometry or coding or whatever, carbide grade or. So I honestly I hope that Toolpath and other technologies like it will make it so that a computer can, like, you can say like, oh, I really like Eagle Claw tools, so my first preference will be Eagle Claw, and then after that I'll go to Kennametal. And then the AI or the software can be like, well, here are 3 tools from your preferred libraries that'll fit your geometry, right?
Right.
And then hopefully that'll make it so that like we can all spend less time paging through catalogs.
Right.
Yeah. But I have to be honest, I agree with you that I think at the moment a paper catalog with like some sticky bookmarks in it is the fastest way for me to order tools,
Right.
which is a little wild.
Which is, if you have like all the thread mills from every company, they're all pretty much the same dimensions. So once we figure out like the dimensions for that, it'll work with it. And just like end mills, if you have a 1/2 inch with a 30th corner radius, it's just you choose whatever end mill from whatever supplier you want, which makes it pretty easy for end mills. But yeah, thread mills, I don't know anybody that really has a catalog for those, but some people have different dimensions because you have some people prefer like the inside diameter thread mills and then outside diameter, and they have different geometries for both, where we just have the same geometry for inside and outside. You can make a for job shop, that's a pretty easy thing to do. So like the outside diameter thread mills, they have a wider crest flat in the bottom, which we'll just keep it for the internal. But I always just tell people, like, take 2 more passes, move it over the same amount each way, and then you can have an external one, so you don't have to buy a separate thread mill for both.
Okay. All right. When you give end mill, thread mill geometry, do you include the size of that flat as part of the spec you give
Yes.
the customer?
Yes.
Okay. Yeah, because that's important for calculating like your step over amount, right?
Yes. Yeah, so like a lot of custom thread mills, I just send a blueprint and has super detailed blueprint of it. And also we'll do auto inspection with a certificate of the dimensions for it. Sometimes we'll laser the dimensions on the tool, just easier for the operator whenever they get to it for production type settings.
Not everybody gives the flat size in their thread mill, so I appreciate that.
Right. They're all over the place, actually, for different companies.
Yeah, which is one of the reasons that I've been told people dislike thread mills. They're like, if I buy a tap, I'll get the size thread I need. But if I buy a thread mill from you versus I buy it from Helical, or I order sometimes the same size thread mill from McMaster can be from like 2 different companies.
Right.
And then all of a sudden your thread doesn't fit anymore.
Yeah.
Doesn't pass the gauge. Okay, how does the size of the flat, like, does it affect tool life? Like, why would I put a bigger flat or a smaller flat on there?
So we typically go from the standard, we go 3/1000 smaller. So you have a lot more adjustment, and you don't want, depends on what fit you want. But we also do a root radius for all our thread mills, which is the strongest form you can do. A lot of people do flats in the bottom of the thread mill. The issue with that is whatever you do a thread mill, your threads are cut straight. So there's no spiral to them. What you're basically doing is scoring the tool. So the smallest diameter of thread mill is the weakest point of it. So that's usually where a thread mill will snap, is in the very back of the shank, the last thread. It's just scored. So if you have a root radius in there, it's not really scored. It's a lot stronger. Even if it's a 5 thou radius in there, or 3. I mean, usually we'll go 3 to like 25 thou radiuses, all in between, depending on the thread mill. But you want a root radius in there. Some threads require that root radius is put on the crest flat of the part when it's in there. It's going to put a lot of wear and tear on the thread mill. But when I put a crest flat on the tool that's 3 thou smaller, you have a lot more adjustment for it when it starts wearing out. And you have a lot more adjustment to do different type fits on your thread tolerance.
So when you say smaller, you mean like literally the flat is shorter?
Not shorter. It's just thinner, not as wide. So usually, like if it's a standard 12 thou, we'll go down to 3 thou smaller. That way you can go deeper. And I want to staying away from for most threads, you don't have to have the root of the thread mill cutting. So you want to stay away from that because it's going to put a bunch of tool pressure on and it'll wear out quicker. So I was like, it's not even going to touch the root. Because another issue, like a lot of thread mills, people snap them because they hit the bottom of the hole with the thread mill and there's no end work on them. And they don't even realize it. And you're not going to notice because it's not going to leave any mark because there's no end work. It's just going to rub and just snap instantly. So most people snap thread mills that way because they didn't get their hole deep enough or they had some kind of clearance issue. The ends don't cut. I've made tons of end mills. When I have people with that issue, I'll put end work on it and they go, oh, I don't snap them anymore. And they don't realize it cut the bottom of the hole now. Which I thought of a long time ago. I was like, oh man, should we just put end work on all our thread mills so this never happens? But it never really happens when somebody is really consistent on knowing their hole depth, and like they go beyond the angle. So a lot of people leave the angle of the drill on there, and that little angle hits that part that has no cutting or clearance on it, and they snap them like all the time. So I was like, but it's very rare people do that. And you run into some people, like you're saying, trying to get people into thread mills, and they start running the issue, and they're like, this is why we don't run thread mills. Like, hey, go a little deeper on the hole. I can like see that it's rubbing down there. And like, that's the only thing that really snaps them. Because you go like on thread mills, you go the least amount of flute depth, and they're pretty strong. Like they're pretty robust. So it's like there has to be a real issue while you're snapping a thread mill, because we run thread mills, tiny thread mills in the hardest of materials, and never have any issues with them.
Okay. I know there's like some companies out there that'll make a thread mill that'll cut its own hole.
Yes.
That's the end work you're talking about, but I never thought about.
Right. That's a different thread mill. So those are, we make a whole bunch of like combo thread mills, but those have like gotten into those have become like real popular lately, where it's 3 teeth. One cuts the thread, 2 rough it out for harder materials. And then you have end work. It's kind of like a high feed mill end work on it. So it could, because when you're circle interpolating, you got to go that pitch distance, and you're like, oh, well, it's D2. And you're like, oh, well, this thread has to go 72 thou every 360 degrees. And then that stuff's got to come out and make a thread at the same time. And we make a lot of those, actually. We just haven't put them in the catalog because the mold makers love them, because they just go to them. They're like, I don't have to do a drill. I don't have to do or worry about the hole. It makes everything all at once. And we don't really have any tolerance. It's just going to hold the like mold into place. Right. So they're just like, we got the thread, everything all at once. And it's pretty much job shop work for a lot of mold shops. And that's how I sell a lot of those too. And I make those, they're not popular like enough to have as like a standard. And we sell to a lot of distributors, and the distributors don't really like those either, where we make a lot of like just the 3-form thread mill. It just has the 3 teeth. And most people are like, we're already making a hole. We don't need to like try and switch everything up. The drills works great. So we get our hole tolerance right. And we just need something to hold up in like harder materials. And we have a lot of different thread lengths for our stuff. And the 3 teeth thread mills work out great, and the distributors love those, and they're more universal than those.
I've been pressing a lot on people lately to keep more tools built up. Like when you buy a tool, buy a holder.
Right.
And that, like, sometimes that hits a wall when people are like, well, I am not going to put every drill and every tap in a holder. Right. I talked with somebody, Alex Rossner, recently, who was like, I spend more money on the thread mill than I do on a cheap holder. Right. So, or on a tap or a drill. So like, what's the problem here? So I think he has like hundreds of holders set up, but there is a limit. And so I hope that at least for people like job shop people who are doing a lot of different threads, that these combination tools so you only have to set up one thread mill, and then you can do, well, I don't know. It depends. Probably like depends whether you're using a single pitch or a single tooth one or not, but you can do a bunch of different threads, but it also saves you to have to get the drill and everything. So
right.
If I had to guess, I would say there'll be a bigger adoption of those tools moving forward,
right?
For people who do high mix work, just because it's one less tool to load, one less tool to stock, one less tool on the shelf. But it is hard to argue with like the efficiency of drilling out material. So
right. Well, that's like the whole issue of a job shop is you need every drill, you need every thread, you need every this. Where you have the thread mill end mill, and it has the high feet end. And I was thinking like one of our new developments is going to be, let's just make the high feet end mill, make it small, and you can make a whole bunch of different size holes with it, whatever material you need to do, and then make a single point. And then you can just chase with a single point and do multiple threads with it. And then you'll have your hole in your thing, but you don't need a whole bunch of different drills. But that's kind of like iffy too, because you got to have all the right sizes for that. And I'm pretty sure that's why all these companies have developed the high feed mill end, and then your 3-tooth thread mill. But they're all specific. So you have the only problem with 3 teeth is you're still going to have the pitch on it. So you're only going to be able to do one thread.
Right.
But
Right.
I think it's like mold shops only use like 4 different threads anyway, most of them. So they just buy 4 of those, and we make a bunch of those. They're pretty popular, but you can't really do them on small stuff. And then I found out, because I was trying to develop it for aluminum, and you could fly with aluminum, the pitch doesn't matter. The only issue is you got to get the chips out, so it has to 100% be coolant through. So we've run it and tested a billion times without. I was like, man, we got to make them without coolant. Only issue is when the chips start flying out and you're making a thread at the same time, it'll booger up the threads even on smaller stuff. Because I was like, this will be like a game changer for quarter 20s if you do this. Nobody has to drill that hole anymore for aluminum. They can just run the pitch and it'll be super quick. Everything's done. Through a hole, bottom hole, it doesn't matter. But it didn't matter. Without coolant through, it's not going to work. And pretty much everybody runs those center coolant. If you want to do, you could do like 4Y coolant or split coolant on the end, but those are custom blanks. I was like, this is going to be too pricey, especially for aluminum. You can just do a drill where we make 3 flute drills. They last like 300,000 holes. And I was like, nobody's going to bat an eyelash. I'm not saving anybody anything. Or you could just do 3 flute drill and they have it for quarter 20s and run them all day, and then a thread mill. And it's just as quick. It only takes up 2 tools where like you do run into the issue of you run out of tools. So we do combos. So like one of our big ones is we make what's called a thriller. So it's a drill end and then a thread mill on it. And then you have a chamfer. So you drill down, chamfer, come back, and then thread mill. The only issue with that is it really only works for a through hole. And then people who don't mind having a weird drill end like hole in their bottom hole. And the bottom hole that they have, it's going to be a weird like drill shape and everything. But I was like, it's usually kind of the shape anyway, but for a quarter 20, it's not really going to matter. But I was like, this will work. These work for quarter 20s. We've sold a bunch of those for quarter 20s, but that one also kind of needs through coolant too, because you make a bunch of chips that'll booger up all the threads that you have anyway.
Well, TSC is getting, like, most people get TSC on machines these days. So
Right.
I think it's a reasonable request. Okay. Your Eagle Claw tools, look, I'll be honest, I haven't tried them yet, but tell me about them. They're like crazy affordable. So, do you do the coating? Do they do the coatings in house? Is that all your own geometry? Tell me about how that works.
So the Eagle Claw, I'm never done developing it. Every batch I make, I improve something on it. We run heavy amount of production as hard as we can in the back all the time, always using Eagle Claws. And every time we're running it, we really look at how long it lasted. We kind of quit documenting they last so long. Like, I don't remember when I put it in. And the other issue is whenever it fails or whenever they're done with it or it's worn out or whatever, we study the hell out of it, see where any issues were, and then like we'd fix it. And then and always developing it. So like, I mean, just recently we've started polishing the flute, which helps out with chip evacuation, because the DLC, it's like I said, it'll double tool life every time, even if you have a crappy tool or the tool isn't that great. But these we've developed and the tool life doubles, but that you're talking 6,000 minutes in the cut at the highest, the fastest your machine can run and the hardest. We ramp with them 45 to 50 degrees. 50 degrees is kind of ridiculous. If the tool, when the tool does fail and it snaps in a production situation, it's going to make you're going to have issues. So we usually just ramp them at like 30. They really don't make any noise. Chips come out, don't need coolant through. The DLC, it works great, but it is sticky. So it does get rid of that, but polishing the flutes has helped out a lot. We do like a double flute on it. We have like a tapered flute on the end. So when you're ramping, the chips flow out, no issue. We have chip riggers on the end, which we've gone back and forth on a bunch of times. But chip riggers on the end really help out with ramping. Slow or fast, they really break up the chips.
On the bottom of the end mill.
Yes, so breaker. The end of it. So
okay, wow, I didn't realize.
So you have chip breakers on the end, which help out a lot with that, and they cut down on the noise that you get from the DLC. They have no issue like ramping when you do rampus. The chips break up. You don't have any issues of sticking.
When you say ramp, are you talking about like a linear ramp or like 30-degree helical ramp?
Either way. Either way. So we do it both ways. We try every time Travis is making a part, I'm like, hey, let's ramp this way. Let's ramp just straight like a ramp, or let's helical ramp. You have weird pockets. You have this, you have that, super deep. We've made them super long, extra length. Because our first thought was, let's just make standards all super long length because it doesn't matter. Like people love, because usually people are like, oh, the shorter tool, it's stubby. Now it's stronger. Like, no, these don't care. Instead of 1.5 inch length of cut, let's just go 2. It holds up. We tested, and I was like, let's just sell it with long length of cut. But then it's pricey, because then over the then I go to helical, and you're like, oh, well, there's stubbies way cheaper. So you have to make every size, and it does kind of make sense to do every size.
And it's cheaper because less grinding and a smaller blank?
Right.
Okay.
Well, still it is going to be less grinding, but cycle time doesn't really matter because we run a lot of lights out. So cycle time is just null and void when you run lights out. You come into a loader of stuff, and then you're going to stock it. So you have it in stock. You don't have to add price to the tool for having it in stock. It ran while nobody was here. There was no overhead to it, and you kept the machine busy all night long or like all day or whatever. But cycle time, we used to do $1 per minute for cycle time, and I was like, I really don't have time to calculate this. It doesn't really make sense. I can't really put it into anything to calculate price for it. So I was like, it doesn't really matter. I have to beat everybody's price anyway, and we need to sell tools. So it's not like I can go like, our Eagle Claw's awesome. The price of performance warrants this $300 price tag. And then I'd just be like, oh, well, our shelf is full of tools that never sell. So, you're just going to have to stick with price and performance and beat everybody else anyway. So I've given up on cycle time.
45-degree ramps or even 30-degree ramps they just look insane. I mean, I think I did 20 degrees once, and I thought it looked like plunging. So
right.
Okay. I did not know that you have a chip breaker on the end of the end mill, probably only for the rougher, but that's interesting. And that's what helps it get the chips out during ramping. I guess that makes sense.
Right, which I could put them on a finisher, but it's not like you're going to take a finisher and start ramping and
ramping into it.
Yeah, you don't want to like do that anyway. You could, but because it has the same geometry as the rougher, it's just we don't put chip breakers on it, and then we polish the flute, and we don't do honing on the edge or coating.
So it gets ground, then sent out for coating, then comes back to get polished in the flutes.
No, we grind polish the flutes.
Okay.
The coat, it's really consistent when you grind polish the flutes. You just do like a spark out pass, which is just like you're removing a little bit to polish it. The wheel won't hold up if you try and just flute it with that wheel that polishes. But the polishing has helped out a lot. I used to think it was just like a gimmick, but then the DLC, everything was sticking. So you have just like an aluminum smear on it. And then when the aluminum smear builds up, and then it'll quit evacuating any kind of aluminum. And then you turn into a flaming hot ball of aluminum. So polishing the flutes helped out big time on that.
So you polish it and then it gets coated, but polishing ahead of time helps the coating be less sticky, I guess.
Yeah, so even if you put the coating over the polished flute, it's still going to remain slick. I mean, it's not, we could put it through a drag hole, but I don't want to like touch the cutting edge and remove any of the coating. I mean, it's really hard to remove the coating, but I was like, it's not sticking, so I'm not going to mess with it, and I'm not going to like polish the coating. Where I have, you can run the tool backwards in the drag hole machine, and it just polish the coating, but like it still has to go the clockwise way and hit the flute and everything, the polish really doesn't matter from the drag hole machine. So we just kind of avoided it since we haven't had any issues with it.
How much? So I'm looking at your 3/8 inch and a quarter length of cut Eagle Claw rougher is $54.32 on the website,
right?
Which is a great price. How much of that is the coating? Like, what if you sold me an uncoated one? What would it cost?
It would be, I mean, the coating isn't much. I think it's like $2 a tool. So I don't even really add it to the price. Right.
Okay.
And then we do huge batches of tools to get coated, but we've been working with our coaters forever, and they always give us the best price. When DLC first came out and they only had one machine, it was probably about $30 per tool, but then they got more machines and they're like, yeah, we're going down like way in price. And then they hold prices for us pretty good. Their material has been hit with tariffs. It's just like, it was minuscule. It's like 13 cents extra. And I'm like, well, to add this price to the tool, it's going to be like 1 million tools in our library. So it's not even worth it for me. It's like cheaper for me to like not do that than just keep the price low. So I was like, it's just more time involvement for me. Like, oh yeah, I want to stay till 9 o'clock to add 13 cents per tool. Like, yeah, I'm not doing that.
Okay, well, I'm going to get one of these Eagle Claws and I'm going to give it a try. It'll see. I've never actually run a coated rougher before for aluminum. So,
right.
I'll be interested to hear the sound difference because it's going to be crazy loud.
I'll send you both. I'll send you both for tests.
Oh, okay. Yeah, I'll put a YouTube up of testing it. I'll get like a decibel meter or something.
Right.
Man, the sound is fascinating. Let's circle back to that for just a second. So it sounds louder. The spindle load change at all with the coating?
No, it doesn't change much. It is louder. It's noticeably louder. We just kind of laugh and we're like, oh, it is louder. Like, that's pretty wild. Because we just usually run uncoated because whenever I set the tools up, like whatever tools I'm setting up, when we get like the first one, it's run on scrap. So when we buy scrap, I also save like anything in scrap that has a really long shank still on it. I save those, we cut them off from those are setup pieces. So that's another reason why our tools are a lot cheaper. I don't have to waste blanks that I buy for setup pieces. So all our setup pieces, like, oh, it's 100% good. And I go give it to Travis. And that's all our, like, that's every tool we make, like every setup piece. Like, so he's got fully stocked on thread mills and everything. So any end mill, and like, he's just got all these drawers of tools. Like, I don't even know what to do with this one you made for TI-17 titanium. It's not going to work in a video. It's like, oh, we're not running TI-17 at all. So I was like, just hold on to it. It's a good tool. And then if someone calls me and like, hey, I need something for TI-17, I go to like the Travis drawer. I'm like, oh, remember that weird tool you said you're going to run? I got a customer for it. He's like, no way. I was like, yeah, let's send it to him. When
you make a tool for coating versus an uncoated one, do you grind the uncoated one a little bigger and the coated one a little smaller?
No.
To account for coating thickness?
No, because they'll never get the coating right, and it's just a giant headache for us. Like, they'll never get it right to get into it. Like, I can't count on them to hold a tolerance for anything, so we avoid that for tight tolerance stuff. End mills, it doesn't really matter, because end mills, you're going to grind up sharp, which is you're going to reduce the diameter of the blank anyway, and everybody usually has like a tooth out tolerance below like the blank size, and we usually hold like a thou. So, and then when you add coating, you're going to get back closer to the blank size. And if it's over, it doesn't really matter anyway, because people are usually going to make a cut and test it and measure it and everything anyway.
Okay. Man, if the sound is different, that's so fascinating. I'm just going to have to do more research. I'm really looking forward to testing that out. That's so cool. That it sounds different because of the coating. God, the physics there must be insane. I think somehow you have exhausted all of my questions. I guess I have one more question. Since you're always sort of tweaking the Eagle Claw, like if I ordered an Eagle Claw from you now and I ordered one a year from now, they're going to cut maybe a little bit different?
Oh, for sure. Yeah,
okay.
Always.
Right.
I mean, it's close. We just do little tweaks here and there for longevity of the tool.
Okay, so you're really focused on life at this point.
Right. And then, like you said, like the noise difference, it's usually people with brother machines. Because people with brother machines, I'm like, the majority of brother owners will run a 3/8. Everything they run is a 3/8 rougher. And I tell them, like, you could rate 45, but let's not do that on your brother. Like, it'll do it. And they're like, I'm not doing that. And I'm like, let's go 35. It'll do it all day. And they're like, I'm not doing it. Then they do it and they go, yeah, we're going 35 from here on out, even though it sounds very sketchy. It's just sketchy, but go 45. No, I'm not doing that without cooling through. I'm like, you're fine. You don't need cooling through. It's going to just disintegrate the chips. They'd be gone.
Wow.
And helical ripping. But I got a couple people and they're like, yep, we go 45 all day. Well, you're right. We didn't need cooling through. It's really shallow stuff most of the time. But I'm like, yeah, if you're going full length of the end mill, just go 25 to 30, whatever you feel comfortable with. I was like, it'll do 45 all day. We do it all the time on old beat up Mazaks, and they really don't care. And we go 50, and we're like, we don't need to go 50. That was the most ridiculous looking thing ever. And if that tool snaps or something happens, that's going to be bad for the spindle, for everything, the holder, and trashing holders. We're like, yeah, we don't want to trash holders anymore. All the Akinel we do, we're usually going through holders a lot, so. Like when tool snaps to run an Inconel, the holder's gone. We use a lot of hydraulics for roofing. And we're like, yeah, they're kind of pricey. Usually you can put a sleeve in it and you'll just destroy the sleeve and it's like $75. We're like, let's not do that. We're putting run out in it. And we also, the Inconel part, we run a really long drill. It's a 3-inch deep hole that it runs in a Y shape. It's a 625 hole, and then they meet in a Y shape. So that's the biggest issue.
Yeah,
yes. Okay. So when you do that, the first hole is great. And then we built a brass plug, and we plug that side, do the other side, so we don't lose our coolant through the other side. when it breaks through. It's breaking through on an angle, and that's like the depth of every drill, which I've designed and made like 20 different iterations of a drill and coolant through. But we don't also have like high pressure coolant. I think that might be an issue where I was like, we need to get a chip blaster. Like, it's because we've been drilling this hole, and it's kept me up at nights a lot. And I was like, you know what? Since I used to work at Walter, they have this drill. They'll bring in a bunch of experts. We'll have them run it. And that drill's been working great. But you just meeting up in that Y in the center is like just a hassle. And whenever we drill it, you get 2 inches deep, and we got another inch deep to go, and nothing's coming out of the hole. And it's real nerve wracking, but it just keeps going. And we're like, we run them all the time. We're like, oh, we hate this operation. And Travis will always pass it off to his wife and be like, you run this thing. We're so sick of this thing. And she'll sit there with her hand on the feed rate button. And we're like, well, you get some anxiety today, not us. So, but I was like, and with the Walter drill, they've like, all their drills they do the same thing with their drills that we do with our Eagle calls, like always refining them and buying new stuff to make them better. And they brought coating machines in-house and did all that. And those drills run great. Like, I always had, like, drills, we make tons of drills, but when people stock them like Walter and they do all that stuff, it's really worth it to buy from them, even with the added price. And I always recommend those drills. They're actually priced really great for what they do, and they are great, and they have their speeds and feeds dialed in for all those drills. And like usually, like I tell people, like I could copy them, but it's just not worth it if I'm making you like 2 drills and they have like 1 million in stock, and it's the wait time for me, and they already have them. You're just going to be better off in their speeds and feeds. They'll send a rep over there. They'll run it with you. They'll make sure. And if they have an issue, and like, I mean, the rep came here and they're like, just run it at this crazy speed and feed. We're like, no way. And then like, it ran it, but like nothing was coming out of the hole. And we're like, here's the part where like these blow up, and we scrap these Inconel parts. And they're like, just do it. And we've been doing it, but just that Y intersection, it's so iffy every time. Even though it's the same thing where we'll get 12 holes out of a drill or 40. And that's how it is every single time we run them. We're like, I'm so sick of them. I don't want to make them. I'm so sick of like waking up in the middle of the night with that vision in my head of like nothing coming out of the hole 2 inches deep. I'm so sick of that. Like, it haunts me like all the time. Like, my son was like, what's the scariest movie? I go, oh, watching the drill in the back with Travis. I was like, that's not, because he's never seen a scary movie. And I was telling him, like, I was like, oh, you're not old enough for him. I was like, man, when I was your age, like 9, that's when I saw all the scary movies. I was like, yeah, Freddy Krueger just doesn't hold a candle to this drill that we run in Inconel. And when you can scrap this $1,800 part over the stupid hole, and we've already put all this time and effort in machining, it's like the last thing we do on it.
Wow. I've never drilled a 3-inch deep hole in Inconel. I'll have to come watch it sometime.
It is rough. It's fine for the first 2 inches and everything's going great, but I was like, we need a chip blaster, the like last inch. And then when it starts breaking through on the second hole, it's a nightmare. It makes all kinds of weird noises, but still works. So we're like, all right, we keep doing it. It's just a part we've run like nonstop. Because we subcontracted from the other company. They're like, we don't want to drill this anymore either. We're like, all right, we'll take it. Fine.
We don't want to drill this anymore.
They don't even like quote us anymore. They just, whenever they get the material, they bring it over. We're like, oh man, another 1,000 of these things. Like, no, that's 2,000 holes we got to watch drill. Like, that's torture.
All right, Dave, this was great. Why don't you tell everybody where they can find you online?
Instagram at Carbide Cutting Tools _SC. I run the page. I'm there all the time. You can message me there. DaveStanbach at gmail.com. You can send all your step files, quotes, blueprints, everything you got there. And that's pretty much it. And my phone number for scrap is just 864-350-1110. So I have our shop phone forwarded to my cell phone, and it's just nonstop calls all day, so it doesn't matter to me anyway.
All right. Well, thanks again, Dave. We'll talk to you soon.
Yep. Thanks for having me. Yep. Bye.